Okay, so today we're talking about RStudio, and in particular how to manage your projects in RStudio with an emphasis on reproducibility. So for those that don't know, RStudio comes in two flavors. So there is an RStudio desktop version, which you can just run and download on your own local machine. But we also have a version of RStudio on our servers, which runs by at this URL, and you just log in using your existing account details, and then you can access all the software and the data that is on our server. So we generally recommend this if you are using very large data sets. Otherwise, sometimes it's nice just to have your own RStudio version on your own machine where you're not relying on an internet connection. There's a few things that I will cover in the demonstration. The first one is Git. So Git is a command line tool for software development. It essentially allows you to track changes in your code and manage different versions. It also is used a lot in software development where multiple people are collaborating, and allows you to create branches in your code. So there's a small sort of infographic here. Rather than creating, as you may have done in the past, many different versions of the same text file or R script file, which quickly becomes confusing and many of those become out of date. You can use Git to track all of the changes in your code. You can release certain versions of your code, so you can always refer to those previous versions if you need to use those. You can also create branches of your code where you can, for instance, develop your code before you release a published version, or use it to create new features in your software. So as you can see, Git can be really useful if you have code which will change a lot, which you are developing, or which you are especially developing with multiple people. And we will probably do a separate session on Git at some point and using Git on the command line. Within RStudio, so RStudio has its own Git interface, and there's a couple of commands which are sort of the basics of Git, where we have a git add command and a git commit command. So essentially, when we make changes to files, we are going to add them to our Git staging area. And then once we are sort of happy with all the changes we've made, even to multiple files, we can then do a git commit, which essentially makes an updated version of our code. And so Git also works with online repositories. You've probably heard of GitHub before. There are also other repositories like GitLab or Bitbucket. These are online code repositories where we can push our code. That means that we can store our code somewhere other than where we create it on our computer. It means that we can make it shareable and also transparent if we want to publish our code to the internet. And of course, it just provides a separate backup as well. So just in this diagram here, if you think about it, your working directory is where you're working on your code. When you make changes to a file, you can add those to a staging area. Once you have maybe multiple files where you've made changes, then you can commit those changes to your local repository. And then at any point, you can then push those changes to your remote repository, which in this case would be GitHub. Similarly, you can pull those changes that may be to a different computer or even a different user. And there are also commands for essentially checking out code and merging code or reverting to previous versions of your code. The other thing we'll really be working on today is something called renv. Now, last time we talked about Conda as far as managing packages for command line software and tools. Now, Conda does have some R packages in it, but it's not comprehensive. And so it's quite difficult to manage your R packages and software versions using Conda. And so we recommend, if you're using RStudio, to use renv instead. So renv is an R package for managing R packages, and the renv is just short for R environment. So the way renv works is that you initialize renv within an R project or a working directory. And then when you go to install R packages, it will install that within a certain project. It will then keep track of all the package versions and also the R version in what's called a lock file. So these packages will remain the same and constantly the same versions in that project, even if you update your packages outside of that project. And to avoid basically storing separate packages in every single project you create, renv has this cache folder. So it essentially means it will install an R package in one place. It can then share it between multiple projects, and the versions it uses are all tracked by this lock file. So renv as well has a few basic commands in the R console that you can run. There is an init command, which you can use at any time just to initialize an renv environment within your working directory. There is a snapshot, which basically takes a snapshot of the current environment and the packages that you've installed. So this will update your lock file. And there's a restore command, which allows you to download all of the R packages which are within the lock file and install those within your project. So finally, I also mentioned that we would take a brief look at RMarkdown. So I just want to go over what that is. So RMarkdown is essentially a markdown language, which is written with R, and is capable of turning your R code into publishable formats like PDF documents, web pages, Word documents, even things like PowerPoint presentations as well. It means that you can publish both static and dynamic content, so you can have interactive visualizations and graphs through RMarkdown. And it's a really nice way just to publish your code along with explanatory text or annotations and the actual outputs from R as well. So you get to create, in most cases, we use this to create websites or web pages where we have our analysis code, some text to explain it, and all the plots and tables, etc., along with that. So the way RMarkdown works is Markdown is just a language which annotates plain text documents. So for instance, you can use hash symbols to create headers in your documents. You can use these backticks to create chunks of code, which can then be interpreted by the R compiler. You can use asterisks for bold text and also italic text, and you can insert web links and things into your RMarkdown documents as well. So that is just sort of the brief intro. So the first thing I'm going to do now is just go to my RStudio. So at the moment, you can see from my project drop-down menu here that I'm not in an existing project. I've got my R console here. And what I'm going to do is just load the library RMarkdown. Okay, and we can see that that's fine. I've got that library, and R will load that library for me. So from my project dropdown, I'm now going to create a new project. And we basically get three options here. So I can create from a new directory, I can associate an existing directory with a new project, or version controls. This is where I can check a project out from an online repository like GitHub. Probably for most of you, you will start by creating projects within RStudio. So we're going to start here. We'll see there's a few different templates that essentially RStudio has for creating different types of projects. So if you were creating an R package or a Shiny app or even a website, you can select these, and RStudio will set up the right files just to make that easier for you. If you're just doing sort of data analysis, then you probably just want this new R project. I'm going to give it a name. I'm just going to call it my analysis. It's fine to go in this folder here, and you'll notice these two boxes, which you may have seen before or may not know what they do. So this is sort of the focus of what we're going to look at today, creating a Git repository for a project and also using renv with this project. So I'll go ahead and create. So we'll see it's just initializing the R environment, which means it's going to install renv, and we can see it's done that. So we now have renv version 0.15.2, and it's also written this lock file. It's now just going to reload the R session in my new project. Okay, so there's a few things that we can see here that RStudio has set up already. So I have an RN folder, and I also have these .getignore file, which we'll look at in a little bit. You can also see that I have a tab up here called Git, which you wouldn't see unless you initialize a Git repository. So let's take a look at the RN folder. Within that, there is a folder called library, and this is where it's going to install all of our R packages. So this is R version 4.2. And we can see we have one folder here, which is the renv package itself. We can also look at the renv lock file. So we'll see that this stores information about the R version that I'm using, and then the packages that are currently installed. So there's only renv at the moment. If I try to load RMarkdown again, it will say there is no package called RMarkdown because it hasn't been installed within this project. So the first thing I'm going to do is just go ahead and install that. So install packages. Okay. And so you'll see that RMarkdown has been installed. It actually says this linked cache. That's because I already have RMarkdown installed in my renv cache folder from other projects. So it's just going to link it to this project. And if we now look in the renv library, we see that it has installed RMarkdown along with a lot of the other dependencies for RMarkdown. If we look at the lock file, we'll see that that hasn't been updated yet. So I have to tell RN for using the snapshot command when I want to update my lock file to represent the packages that I have installed. Before I do that, I'm just going to create a new file within this project. So I'm going to create an RMarkdown document. So R is just telling me that to edit an RMarkdown document, I have to install a few other dependencies. So it's going to go ahead and do that as well. So it's just installing these Markdown and MIME packages. Okay, so we'll just call this my analysis 1. And there are a few options here about the output that we want from RMarkdown. So again, you can see you can choose presentations or Shiny applications or a document. And within documents, you can choose HTML, PDF, or Word. Normally, I just use this to create web pages. So this is our RMarkdown document. We'll see that it has a header, which is just separated by these 3 dashes. We have a title, which will end up as the header of our document. We can put extra information in there, just for instance, the author and the date. The output here is HTML. There are quite a few different other options that you can add, like adding tables of contents or sort of customizing table outputs and things like this, all in the header section. You'll then see that there is a code chunk. So these 3 backticks here represent a chunk of code. And the first argument here is just R, to say that this is R code. It has a name, so just setup. And there's an option here which says include as false. And so that essentially means that we're not going to include this in our output. So what we're doing here is just setting some default options for the entire R document within this, this first code chunk. Now, each of these code chunks have a little cog just for settings. And so you can do things like decide if you're going to show the output only, if you want to show the code and the output, if you're going to show nothing, etc. You can also turn off warnings and messages that are sort of spits out by default. So below that, we then have some markdown text. So this is a header, which is marked by these 2 hash characters. The number of hashes that you use means the size of the header. So that would be a sort of main title. This would be a level 2. That would be a subtitle. We then just have some plain text. There is a web link embedded here. This knit word here has 2 asterisks around it, which just means it's going to show as bold in our HTML output. We then have another code chunk. So again, this is just running R, and it's running code for the summary of the cars data set. So cars is just the default data set within R. And then underneath this, we have a plot from the data set, which is called pressure. And you'll see that there's another option within the RMarkdown header, the code chunk header here, which says echo equals false. So what echo equals false means is that it's going to plot the output of this R code, but not the R code itself. So this is just sort of the default template that when you create an RMarkdown file, it will give you something like this. I'm just going to save that. And I will also just call it my analysis 1. So we'll see that it now appears in my files down here as an RMarkdown document. Now, the way to turn your Markdown into HTML is to do what's called knitting. And so there is a handy little knit button here, which will just, it will render the RMarkdown document into HTML. And so you can see this job is running at the moment. While that runs, if we go back up to our Get tab here, we'll now see that there's been a few files added. So there are some changes to this, this project. And so we now see that the My Analysis Markdown document has appeared, as well as all the other files which are currently in our directory. Yeah, so you can see that it's running through here, it's creating an output file, and it should just pop up on the screen. Okay, so this is the output of our RMarkdown file. So we have our contents of our header. We then have the title RMarkdown. We can see this link. We can see this bold text. We can see the R code and the output. And here we can see the output without the R code being included. So this is a very simple demonstration of what RMarkdown is. There's obviously a lot more to it, but hopefully you can see just the power of being able to publish your R code along with text, other images you can include, web links to other resources, etc. Okay, so we've set up our project. We have initialized our renv environment. And we also have a Git repository. So as I mentioned, the lock file doesn't include all these new packages we've installed. So what I'm going to do is I'm going to run renv and then the snapshot. And that will just look in the rn folder, and you can see that it's adding all of these packages which weren't installed before and this version to our lock file. Do I want to proceed? Yes. Okay, those are warning messages that came previously from the RMarkdown. So if I look at my lock file now, okay, we can see that there's a lot more R packages installed. Okay, so now I have my project, I have my analysis completed in my RMarkdown file, and I want to make a git commit and push this to an online repository. So one thing I don't want to do is push all of these R packages, which, you know, there's quite a lot of them, up to GitHub. So the way we can stop things from being recognized by Git is this git ignore file. So if I open it up, it will ignore all my sort of user data and basic project files and hidden files. But I'm also going to tell it just to ignore the rn/library, I think it is, yeah. Save that. And if I just refresh here, then what I should find is when I click on rn, it's not adding anything under library. So I'm going to go ahead and just add these. So the staged tick box here is essentially the same as using the git add command. And so I need to include my R profile. I will include git ignore and my project, the RMarkdown file and the HTML, the renv directory, which you'll see we're just including the activate.r and the settings and not the library itself. And also I need to include the lock file. So if I want to make this project reproducible so that others can download my renv environment, I need to make sure I include the renv.lock, the renv activate file, and also the R profile. So let's go ahead and commit these changes. So RStudio will bring up a sort of separate window here where we can see all of the files and all of the changes to those files. And because I haven't committed anything yet, everything here is in green to say that's essentially new text to this commit. We also always have to give it a message or a name for the commits. And normally the first one is just first commit. So I go ahead and press the commit. And we'll see that you'll get a bit of text here to say 9 files have changed and that commit is successful. So you'll notice these push and pull buttons are faded out at the moment because I don't have a remote repository that I can push or pull to or from. My Git tab now doesn't have anything in it because I haven't changed anything. So the next step is to go to GitHub and set up an online repository there. So I'm logged into GitHub here. I'm just going to add a new repository. So we'll give it a name. We'll just call it my project. I can add a description if I want. I'm just going to leave it public. That's fine. What I'm not going to do is add a README file or a git ignore file because I already have one of these. So I'm just going to leave it open, empty, and hit create repository. And you'll see that GitHub gives me a few different suggestions of how I can then link this repository to my own. So The one we want here is this push an existing repository from the command line. So it gives me the git commands that I can use to essentially link my repository to this one. And so I'm just going to copy that text. Now, depending on your version of RStudio, if you can either just go to your terminal or you can do it from here. So then the drop down in your Git tab under the settings, there is a shell. But this will really just take you to your terminal and open the working, normally opens the working directory you're in. So I'll go into my project. If you've used Git on the command line, then this will be familiar to you that we're in a Git repository at the moment. And then I'm just going to copy that text that GitHub gave me. Okay. Okay, so what this is doing is the first line here, git remote add origin. So I'm adding a remote repository, this URL, to my existing RStudio Git repository. The next is changing the branch name. So the thing is that GitHub have moved all of their default branches to be called main, whereas they were previously master. And you'll see that RStudio is still calling its default main branch as master. So it will rename it main just so that it matches up with GitHub. And then it's going to push my first commit to the GitHub repository. So immediately you'll actually see that the branch name here for Git has changed to main, which is good. And then I can go to my project on GitHub and just refresh this. And you'll now see that I have all of these files on my GitHub repository. So I have my RMarkdown file, my HTML, my renv lock file, etc., etc. So I have created my repository in GitHub. GitHub's asking me now, do I want to add a README file? I could go ahead and do that. So I could add a README file from the GitHub environment. I'll just add a little bit of text here. So my analysis. And then I can commit this file from GitHub. So we'll see I now have a README file in my repository that's in GitHub. So if I want to bring that into my current project here in RStudio, then I want to pull. So we'll see I can now use these push and pull buttons. I'm going to use the pull command. This just runs git pull on the command line, and we'll see that one file has changed and I've brought in my README file. So that now exists here as a README Markdown file. So at this point, my GitHub repository and my RStudio Git repository are in sync. Let's make some changes. So I'm just going to make a change to my Markdown file. Let's actually just get rid of this echo equals false so that it prints the R code as well in my HTML file. When I save this, I see it pops up in my Git tab to say that changes have been made to this file. So I'm going to follow the same process. I will stage or add it. Then I'm going to perform a commit. So I'll just say update RMarkdown. We'll see that the changes here are what Git is tracking between the two versions of our file. So red is the previous version, green is the new version. We'll go ahead and commit. And now from here, I can also push, and we'll see that it sends this file to my GitHub user account and updates the remote repository. So that's great. So I've figured out how I can use Git in RStudio and push my code and pull my code from a GitHub repository. Now, another useful thing with publishing your code to a remote repository is that others can then download that code as well. And so what I'm going to do here is imagine I'm using another computer or I'm another user, and I'm just going to create a new project. So this time, what I'm going to do is create a project from a version control repository. And I'm going to be using a Git project. So it's asking me for a URL. So if I go back to GitHub, I'm just going to use this code dropdown to copy the URL for my repository in GitHub. So it automatically names this my project, and so that's okay, and it's going to create the project under RStudio. So I run create, and it starts cloning this project into a new project. So RStudio will probably reload now. So it can take a little while because it's also going to recognize that it's an renv project, and it's going to install the version of renv and begin installing the packages as well. So we'll give it a few seconds. It always runs. Things seem to run a lot slower on my computer when Zoom is running at the same time. So okay. Well, I will stop the share and then see if we can come back to it in a few seconds, just to see what that has done. Okay, so I will show you that when it's complete, but that's pretty much the end of the presentation. So to summarize, just a demonstration of using RStudio with a highlight on reproducibility. That is one, creating a Git repository to track and version your code, as well as publish your code online for others to see or to share or to download themselves. Secondly, using renv to manage your R environment and to share reproducible R environments. And thirdly, we sort of briefly touched on RMarkdown and just the power of being able to share your code along with the analyses, plots, tables that you present, again, with the focus on reproducibility. So at this stage, I'll take any questions if anyone has any. Okay, that's fine. So yeah, RStudio has completed opening my new project here. So we can see we're now in previously we were in my analysis, now we're in my project. We can see that renv essentially was recognized, downloaded the correct version, and started to install renv. Now, what we'll see, the message here saying renv, we need to run renv restore to actually install the packages in the lock file. So if I do that, okay, and now again, what it's done is it's looking in my lock file and saying which packages will be updated. I will just hit yes. And again, it's linking these from my cache, so it's fairly quick. If you don't have these packages downloaded, it won't run that quickly. So we can see now within the RN folder in this new project that we've set up, we have the exact same R environment that we shared from our previous R project. Okay, Kashyap, you had a question? Kashyap, did you have a question? Yeah, okay. So there's some questions in the chat. So Kashyap had a question about, does renv save the R binary version? No, it doesn't, okay? So it keeps track of the R version that was used. And essentially RStudio, the free version anyway, will only really work with one R version by default. You can install multiple versions of R on your machine and then sort of change the environmental variables so that RStudio looks elsewhere. So you can manually change your R version to match what's in the R environment. The paid for versions, the licensed versions of RStudio actually work with multiple versions of R. So renv kind of only goes so far as reproducibility goes, but it's definitely a step in the right direction. Okay. Michaela, you're asking, how do you install Git? So it will depend what machine you're on, but I could definitely show you how to install that. At some point, you install it basically on your command line first. Okay, right. If no one else has any questions, then we'll call the session there. I'm going to end the recording, and if people have anything else that they would like to discuss with the bioinformatics team or any questions about your own research, we will hang around on the call for a little bit. Otherwise, thanks for your time, and we won't see you in July. We'll see a few of you next week for the RNA-seq workshop. Otherwise, we'll be back in August, and I will post out a little recap of this session along with the recording of the video and a few other links to other resources. Thanks.